20 years, 4.9 billion miles. One final photograph of a spot on a planet that was about to swallow the spacecraft that took it. On September 14th, 2017, a robot orbiting Saturn pointed its camera one last time. Not at something beautiful, but at the exact patch of clouds where, in less than 24 hours, it would burn apart. It knew where it was going to die, and it photographed the spot anyway. That single image, grainy, monochrome, lit only by reflected light from Saturn's own rings, became the final frame in a 20-year story. It started with a rocket launch in 1997 and ended with a spacecraft deliberately destroying itself so that nothing it carried could ever contaminate the ocean worlds it had spent 2 decades falling in love with. This is the story of how Cassini said goodbye, and why what it photographed in its final hours is still messing with the minds of scientists who've spent their entire careers staring at Saturn. Here's what most people don't realize about the end of the Cassini mission. It wasn't a malfunction, it wasn't an accident, and it wasn't a budget cut. NASA killed its own spacecraft on purpose. After 2 decades in space, having expended almost every bit of the rocket propellant it carried, mission operators deliberately plunged Cassini into Saturn to ensure the planet's moons would remain pristine for future exploration, especially Enceladus, the ice-covered ocean-bearing moon, and Titan with its strange prebiotic chemistry. Read that again. NASA was so afraid of accidentally contaminating a moon that might harbor alien microbial life that they chose to incinerate a billion-dollar spacecraft, rather than risk it drifting, dead and uncontrolled, into Enceladus. That single decision tells you everything about how seriously the scientific community had come to take what Cassini found out there. But to understand why a spacecraft's death became one of the most emotional events in the history of planetary science, you have to go back to where this all began, to a launch most people have completely forgotten about. Cassini left Earth on October 15, 1997, carrying with it a smaller European probe named Huygens, bolted to its side like a hitchhiker waiting for its turn to fall. The plan sounded almost absurd at the time. Fly for nearly 7 years through the solar system, using the gravity of Venus, Earth, and Jupiter like slingshots, just to arrive at a planet so far away that sunlight takes over an hour to reach it. The spacecraft finally entered orbit around Saturn on June 30th, 2004. Think about what that means. A piece of human technology, built with 1990s computing power, had to function flawlessly for almost 7 uninterrupted years in the vacuum of space, surviving radiation, micrometeorite impacts, and the brutal cold of deep space just to reach the starting line. And once it got there, nobody knew exactly what it would find. Saturn had been photographed before by Pioneer and Voyager flybys decades earlier, but those were quick glances. A few days of data from spacecraft racing past at incredible speed. Cassini wasn't passing through. Cassini was moving in. It was about to become the first spacecraft in history to actually orbit Saturn, settling in for what was supposed to be a 4-year mission. That 4-year mission turned into 13 years. And what Cassini found during that time didn't just expand our knowledge of Saturn, it rewrote what scientists thought was possible in our solar system. Within the first year of arrival, Cassini released the Huygens probe, which descended through the thick orange haze of Titan, Saturn's largest moon, and did something no human-made object had ever done. It landed on a world in the outer solar system. What it found waiting on the surface should have been the lead story on every news channel on Earth. Titan wasn't a dead rock. It had rivers. It had lakes. It had weather. Liquid methane seas spread across its surface, and the moon's atmosphere held intriguing prebiotic chemistry, the kind of chemical building blocks that, under the right conditions, can eventually assemble into something resembling life. But here's where it gets stranger. Titan's lakes weren't water. The temperature out there is so brutally cold, nearly minus 290 degrees Fahrenheit, that water freezes into rock-hard ice, and methane, the same gas that powers stoves on Earth, exists as a liquid instead, pooling into seas the size of the Great Lakes. For the first time, humanity had discovered a world with an active liquid cycle that wasn't Earth. Rain falls on Titan. Rivers carve channels into its surface. It just rains gasoline instead of water. And if Titan wasn't enough to shatter assumptions, Cassini then turned its instruments toward a moon nobody had taken very seriously before. A small, bright, icy little world called Enceladus, barely 300 miles across, so reflective it looked almost like a giant snowball drifting around Saturn. Scientists expected a dead, frozen ball of ice. What they found instead changed the entire search for life beyond Earth. Cassini detected enormous plumes of water vapor and ice particles erupting from cracks near the moon's south pole, blasting hundreds of miles into space like geysers. Those icy plumes indicated something almost unthinkable for a moon that small, an underground ocean hidden beneath miles of ice, possibly warmed by hydrothermal activity at its rocky core. An ocean, liquid water, heat, chemistry, the exact combination of ingredients that on Earth gave rise to life around deep-sea hydrothermal vents billions of years ago. Suddenly, this tiny ice moon, orbiting a gas giant nearly 900 million miles from the Sun, became one of the most promising places in the entire solar system to search for alien life. More promising, in the eyes of many astrobiologists, than Mars. And this is where everything changes, because once NASA realized what Enceladus might be hiding beneath its frozen shell, the entire calculation around Cassini's eventual fate shifted with it. For years, the spacecraft kept flying. It watched Saturn's hexagonal storm at the North Pole, a churning, six-sided jet stream wider than two Earths stacked side by side, a weather pattern so strange that scientists still don't fully understand the physics behind why it forms a perfect hexagon instead of a circle. It watched seasons change across more than a decade, as Saturn's 30-year orbit around the Sun slowly shifted sunlight from one hemisphere to the other, turning summer into winter on a planetary timescale almost too slow for a human career to witness in full. It captured storms larger than entire continents tearing across Saturn's atmosphere. It mapped the rings in extraordinary detail, revealing that they weren't the smooth, simple bands people imagined, but an intricate, constantly shifting system of waves, gaps, clumps, and tiny embedded moonlets actively sculpting the material around them in real time. But by 2017, Cassini was running out of fuel. And in space, fuel isn't just for moving forward, it's for control. Without propellant to adjust its orbit, point its antenna at Earth, and keep itself stable, a spacecraft becomes a drifting piece of debris. NASA had two choices. The first option was to simply let Cassini run dry and drift wherever its last trajectory carried it, indefinitely, forever, with no further control. The second option was far more dramatic and far more deliberate. As Cassini program manager Earl Mays put it, an uncontrolled spacecraft either had to be well outside of Saturn, way, way outside, or inside. There was no safe middle ground. A dead, uncontrolled Cassini drifting near Saturn's moon system for decades or centuries posed a real risk of eventually colliding with Enceladus or Titan, potentially seeding those worlds with Earth bacteria that had hitched a ride on the spacecraft since 1997 and somehow survived 2 decades of radiation exposure in deep space. If even a trace of terrestrial microbial life contaminated Enceladus's hidden ocean, it could compromise one of the most important scientific questions humanity has ever asked. Are we alone? Future missions searching for alien microbes in that ocean would never be able to fully rule out the possibility that whatever they found had actually come from Earth in the first place. So NASA made its decision. Cassini wouldn't drift, it would dive. In April 2017, mission engineers committed the spacecraft to what they called the grand finale, and the name was not an exaggeration. Cassini was placed on a course that would unfold over 5 months of daring dives, a series of 22 orbits, each one threading the spacecraft through the narrow, 200-mile-wide gap between Saturn and the innermost edge of its rings. No spacecraft had ever attempted this. Nobody actually knew what was inside that gap. Engineers had modeled it, calculated it, run every simulation they could. But theory and reality are different things when you're flying a 13-year-old spacecraft at tens of thousands of miles per hour through a region that might be filled with ring particles capable of shredding it on contact. But here's where it gets worse. Or, depending on how you look at it, more thrilling. During those 22 passes, Cassini's altitude above Saturn's clouds varied from roughly 1,000 to 2,500 miles, occasionally shifting closer or farther depending on distant gravitational nudges from Titan. Each dive brought the spacecraft closer to the planet than any human-made object had ever flown, gathering data on Saturn's magnetic field, its interior structure, and the composition of the gap itself that simply could not be collected any other way. And each dive was also a gamble, a test of whether 20 years of engineering could survive one final, unprecedented stress test before the mission's planned death. It survived all 22. And as the final orbit approached, the team did something that, on paper, sounds almost sentimental for an organization built on hard physics and orbital mechanics. As Cassini moved toward its final plunge, it spent its last days capturing images of its surroundings, almost like pictures taken with old friends just before saying goodbye. Cassini's own project scientist, Linda Spilker, described the spacecraft's final photographs using a word that stuck with everyone who heard it: a scrapbook. We're taking our final picture postcards of the Saturn system, looking at our favorite targets, to put these images in our Cassini scrapbook, she said, in the hours before the spacecraft's destruction. Think about what that phrase actually implies. This wasn't a machine blindly executing commands. This was a mission team, after 13 years of daily contact with this spacecraft, choosing to spend its final hours photographing the things it had grown to love. Not because the data was scientifically essential, but because it mattered to the people who had spent 2 decades of their lives keeping it alive. So what exactly did Cassini photograph in those final days? On September 13th, 2017, with less than 48 hours left before impact, Cassini turned its camera toward Titan one more time, capturing the moon's hazy, tangerine-colored atmosphere glowing softly against the blackness of space. In these raw, unprocessed images, the hazy moon, Titan gleams, the ice moon Enceladus appears to create what looked almost like a cosmic grin. The giant planet shines behind them, and Saturn's iconic rings fill the spacecraft's entire field of view. It photographed Enceladus, setting behind Saturn's enormous curved horizon, the small ice moon slipping silently out of frame as if it, too, somehow understood what was coming. It captured a sweeping mosaic of Saturn's rings, stitched together from multiple exposures, revealing fine structural detail in the ring material that wouldn't be visible to any telescope on Earth, regardless of how powerful. It photographed Saturn's outer A-ring, where a tiny embedded moonlet called Daphnis carves visible waves into the edges of a gap known as the Keeler Gap. Proof, frozen in a single frame, that the rings were not static, but a living, dynamic system still being shaped in real time, just hundreds of miles from where the spacecraft itself would soon be destroyed. But the most haunting image of all came last. On September 14th, 2017, roughly 14 hours before its final plunge, Cassini's imaging cameras captured one final photograph and beamed it back across nearly 1 billion miles of space to Earth. This monochrome view looked towards Saturn's night side, lit only by reflected light from the planet's own rings, and showed the precise location at which the spacecraft would enter the atmosphere hours later. Read that again. The last thing Cassini ever photographed was the exact spot where it would die. There was no scientific requirement forcing the team to capture that particular frame. They chose it. Taken from a distance of about 394,000 miles, it became the final picture ever snapped by Cassini's cameras. No more images would follow. From that point forward, every remaining hour of Cassini's existence would be dedicated entirely to one final task: gathering and transmitting as much raw atmospheric data as physically possible before the spacecraft's small thrusters lost the fight against Saturn's atmosphere and the antenna could no longer stay pointed at Earth. September 15th, 2017 arrived, and inside JPL's mission control room, dozens of engineers, scientists, and team members who had spent years, in some cases their entire careers, on this single mission, gathered to watch the end in real time. Members of the Cassini team and other NASA employees stood beside a full-scale model of the spacecraft, watching the final minutes unfold together. At approximately 4:55 a.m. Pacific time, Cassini began its descent into Saturn's upper atmosphere, firing its thrusters at full capacity in a desperate attempt to keep its antenna locked on Earth while atmospheric drag increasingly fought to tear it off course. For just under 2 minutes, it succeeded. Engineering data and atmospheric readings streamed back across the solar system in real time, transmitted by a spacecraft that was, at that very moment, disintegrating. Then the signal stopped. Not gradually, not with a warning. It simply ended, the way a phone call drops mid-sentence. Cassini burned up and disintegrated like a meteor, scattering its components across Saturn's upper atmosphere, becoming, in the most literal sense, a part of the planet it had spent 13 years studying. Here's what most people are not seeing when they look back at that moment. This wasn't really an ending. It was a transfer. Everything Cassini gathered over 13 years in orbit, every photograph, every measurement of Saturn's magnetic field, every reading from its descent through the atmosphere, didn't disappear with the spacecraft. Although the spacecraft itself was gone, its enormous collection of data about Saturn, its magnetosphere, its rings, and its 62 known moons would continue yielding new scientific discoveries for decades after the mission ended. Scientists are still publishing papers today, years after that final signal cut out, based entirely on data Cassini collected before it died. The spacecraft is gone. Its discoveries are not. And in many ways, that's the real story buried underneath the cinematic drama of the final dive. Cassini's death wasn't the end of the mission's value. It was the beginning of a new phase, one where human researchers, sitting safely on Earth, slowly unpack a treasure chest of information that will take generations to fully understand. And this is the part that should genuinely unsettle anyone paying attention. The very last thing Cassini's instruments confirmed before transmission ceased was the precise atmospheric composition of Saturn at the moment of impact. Data that engineers had been chasing for the entire mission, and it could only obtain by sacrificing the spacecraft itself. There is no way to gather that kind of information remotely. The only method that worked was to fly straight into the planet, accept total destruction, and transmit everything possible in the final 90 seconds before contact was lost. Every scientist involved in that decision knew exactly what they were trading. A flagship spacecraft, one of the most expensive and capable machines ever built, for 90 final seconds of data that no telescope, no flyby, and no future mission could replicate without repeating the exact same sacrifice. They made that trade. Willingly, almost 2 decades in advance, the moment they committed to the grand finale trajectory back in April 2017. So why does this story keep resurfacing nearly a decade later, pulling in millions of views every time someone revisits those final images? Because Cassini's farewell touched something that most space missions never reach. It wasn't just a triumph of engineering. It was a spacecraft that, in its dying hours, chose, or was made by people who loved it, to choose, to look one last time at the worlds it had spent 13 years falling for, before turning its camera toward the place it would never leave. Some of the most viral versions of Cassini's final moments circulating online today aren't even real. Dramatic artist renderings mistaken for genuine spacecraft photography, fact. Checked and debunked by outlets like Reuters and Snopes years after the mission ended. But the actual photographs, the real, unprocessed images Cassini beamed home in its last 72 hours, don't need exaggeration. The true story is already strange enough. A robot built by humans, who would never see it again after launch, spent 2 decades studying alien oceans, alien rain, alien rings, and then deliberately destroyed itself to protect the very worlds it had fallen in love with from ever being contaminated by the species that built it. What happens next is where the uncertainty really begins. NASA is already building Cassini's successor, a rotorcraft mission called Dragonfly, designed to fly through Titan's thick atmosphere and land directly on its dune-covered surface, searching for the kind of prebiotic chemistry Cassini could only observe from orbit. But Dragonfly won't reach Titan until the 2030s. Enceladus, the ice moon whose hidden ocean forced NASA's hand back in 2017, still has no dedicated return mission funded or confirmed. Somewhere beneath miles of ice, an ocean that might contain the first confirmed evidence of life beyond Earth is sitting there, untouched, waiting. Cassini found the door, just couldn't walk through it. And right now, nobody can say with certainty when humanity will go back to check what's actually on the other side.